Okay, let's take a look at our findings from worksheet A. We are looking at the law of conservation of mass and law of definite proportions, and we examined the data table, the experimental data, from these 4 experiments, and we determined that the masses of reactants always are going to equal the mass of the products, and that's what the law of conservation of mass tells us. Even if we have some of the reactant not actually reacting and becoming part of the compound, we'll still see the same total amounts at the beginning versus at the end. So that's what the law of conservation of mass tells us should happen. The other thing that we saw was this law of definite proportions or constant composition. So when I have a certain compound forming, such as lead sulfide, even if I don't have the same mass of lead sulfide formed each time, the ratio of the masses of the elements making it up, so the lead and of the sulfur, the ratio of their masses is always going to be the same thing. And so that's what the law of definite proportions tells us. Notice that we had these first 3 examples. We had the same mass of lead sulfide formed each time. That statement that the law of definite proportions makes, again, is talking about the mass ratios of the lead and the sulfur making up the compound. So even when we've got, in example D here, a larger sample produced, a larger amount of product produced, the ratio of lead and sulfur used is the same. So the amount of lead that was actually used is larger, the amount of sulfur that was actually used is larger than the previous examples, but the ratio is still the same. Okay, so that's these 2 laws state. So when we look at the data on this 3rd page of worksheet A, if we're asked to calculate the percent by mass of carbon and oxygen in each compound, we're given the formulas here, but notice we're going to take the carbon and oxygen in each compound, add them together. That's going to be our denominator. And so let's do that. So 24 plus 64, that's going to be 88. Let's see if I can write that down here. So that's 88 grams. The percent then of carbon in this compound is going to be the 24 divided by 88 and then times 100, and so that should come out to 27.3%. Do the same thing for the oxygen, and notice that we are taking the 64 divided by 88 times 100, and that gives us 72.7%. Okay. As you'd expect, and these 2 percentages should add up to 100, just to check our work, so that does add up to 100%. So we're doing the same thing for compound 2. So we're given this mass data, so we have 12 grams of carbon and 16 grams of oxygen, so that's going to add up to 28 grams for our total mass. And so again, if I'm finding the percent for carbon, there are 12 grams of carbon divided by the 28 grams, and so right here that's going to give us a 42.9% composition for carbon. And do the same thing for oxygen. So we have the 16 divided by our total mass, which is 28, and times 100, and that gives us 57. Oops. That gives us 57.1%. And again, if I add those 2 percents up, that does add up to 100, so that checks out. Doing the same thing again for compound 3. We've got a total mass of 44 grams, so 12 plus 32, that's 44. So I take my mass of carbon, 12, and that's divided by 44 times 100, that gives me 27.3%. And then for the oxygen, 32 divided by 44 times 100, and that gives me 72.7%. Okay, so once we have the percents, then we can talk about number 2 here. Is compound 3 the same as compound 1 or compound 2? Use your calculations to support your answer. So just saying that 3 is the same as one or the other isn't good enough. We need to say why and cite our numbers. So we need to actually mention the numbers in our answer. So notice the law of definite proportions. Here it is. A compound is always made up of the same proportions by mass, and it's true regardless of the sizes or sources of the samples. So once we find out either the mass ratios or the mass percents, which is what we just did, we found the mass percents, we compare them. And if 2 samples are the same compound, they should have the same mass percent or mass ratio. So notice if I compare compound 1, it has 27.3% carbon, 72.7% oxygen. Compound 2 has different percentages for carbon and oxygen. Compound 3, however, has the same exact percentages as compound 1. So to answer question 2 here, compound 3 is the same as compound 1, and supporting my answer with my data is that it has the same mass percents as compound 1. So again, there's 27.3% carbon in compound 3, 72.7% oxygen in compound 3, and those are the same mass percents in compound 1. And according to the law of definite proportions, if there are the same mass percents or mass ratios of the elements making up the compound, it is in fact the same type of compound. And so again, we'd see the same properties if we had an actual sample to test, have the same chemical and physical properties, thus confirming it is in fact the same compound, but our mass percents will be the same as well. All right, so for number 3, we're doing some ratios. So we're taking the mass of oxygen in compound 1, and so that is 64 divided by the mass of carbon, and that's 24, and so that's going to give us a ratio of, and it says to give us 4 digits, so 2.667 is going to be the ratio. I'm going to do that for each of the compounds, and so we've got 16 for the mass of oxygen in compound 2, we've got 12 for the mass of carbon in compound 2, and then that gives us a 1.333 for 4 total digits. And then in compound 3, we have 32 for the oxygen, we've got 12 for the carbon, and then that gives us a ratio of 2.667. Okay, so comparing the number of oxygen atoms to the numbers of carbon atoms in each of the compounds above. Notice that there's 2 oxygens for every 1 carbon in compound 1 in the picture, and there's 1 oxygen for every 1 carbon in compound 2. So if we take a look at our numbers, so notice the ratio, mass ratio for compound 1 versus 2, well, this is actually twice the number, so 2.667 is twice this value. And so it appears that we have double the amount of oxygen atoms, we also have double the mass ratio. And so we can see that from these numbers here. So that's what question 4 is getting at. So that leads us into the next law we have, our third law, law of multiple proportions, and that is when 2 elements combine to form 2 or more compounds, the mass of one element that combines with a given mass of the other is in the ratio of these small whole numbers. So what that means is both of these compounds are made up of carbon and oxygen, but when we compare their mass ratios, we can see they're not the same compounds, but there is some relationship between their mass ratios, and that is a whole number ratio. So that gets us into what we know about the existence of atoms today and what we're going to get into in class. So you're going to read this next portion, page 4 of the worksheet, and then try to connect up what Dalton's atomic theory is trying to explain about these 3 laws that we just looked at. And again, you'll be finishing the questions on page 5, and we'll go over these in class.